We are given that ABCD is a tetrahedron whose base is an equilateral triangle, meaning that the triangle ABC is an equilateral triangle of side 8 cm. We are also given that DA is equals to DB is equals to DC, and all these lengths are 6 cm long. We are tasked to find the angle theta between the plane ACD and its base ABC. In other words, if you look at the diagram over here, we are asked to find this angle DMB. Right, what I'm going to do is that I'm going to draw out this triangle DMB on the space below here. So this is the triangle DMB. We are asked to find this angle theta. For this triangle, we only have the length DB to be 6 cm. Next, we are going to look at various ways to find all these unknown length. Once I can find the length MD and also the length MB, I will be able to apply cosine rule to find this unknown angle theta. So first up, I'm going to look at this triangle AMB. So I'm going to draw it over here, this triangle AMB, and put in all the dimensions that I know. I know that AM is 4 cm. I know that AB is 8 cm. So these are just dimensions that's taken from the diagram. So now with AM to be 4 and AB to be 8 cm, I can now use Pythagoras theorem to find the length MB. So applying Pythagoras theorem to the triangle AMB, I will have 8 square equals to 4 square plus the unknown BM square. So solving for BM, I have BM to be square root 48. So now I know BM is square root of 48 cm long. I'm going to transfer this over to this diagram on the right. So this length MB now I know to be square root of 48 cm. Next, we're going to look at another triangle, and this time we are going to look for MD. So therefore, we're going to look at this triangle AMD. So this is where the triangle is from the original diagram, AMD. So this is the triangle. I'm going to redraw this on the space over on the left. So this is the triangle AMD. Putting in all the dimensions that I know that AM is 4, and I also know that AD is also 6 cm. So AD is 6, AM is 4, and likewise applying Pythagoras theorem to the triangle DAM, I will have 6 square equals to 4 square plus DM square. So solving for DM, I have square root of 20. So therefore square root 20 is the length of DM. Transferring this DM, the length of DM over to this triangle over here. So now the length of this side of the triangle DMB is square root 20. Now that we have found the dimension of all the three sides of the triangle, we can now apply cosine rule to find this unknown angle theta. So applying cosine rule, we will start off with the side that is opposite to the unknown angle that we want to find. So we have 6 square is equals to square root 20 square plus square root 48 square minus 2 times square root 20 multiplied by square root 48 multiplied by the unknown angle cosine theta. So looking at the solving, 6 square is 36, square root 20 square is 20, square root 48 square is 48. This is also the reason why I did not evaluate the length as decimals, but rather leave it in surds form, knowing that there will be squares coming up later on. And minus 2 times square root of 20 times square root of 48 cosine theta. So manipulating this step to this step, I have cosine theta equals to 32 divided by 2 times square root of 20 square root of 48. Now solving for this, alright, theta equals to arc cosine of this. Alright, we have theta to be 58.9 degrees. For angle in degrees, I will round it off to 1 decimal place. So therefore, the angle theta between the plane ACD and its base triangle ABC, the angle theta is actually 58.9 degrees.